Hello everyone and welcome. In this video, we'll be looking at Dijkstra's algorithm. Now, Dijkstra's algorithm is one of the shortest path algorithms. What's it used for? It's mainly used in finding the shortest path between two nodes, so a source node and a destination node in a graph or a tree. And it's implemented mainly in network routing protocols. Looking at the graph we have here, you may be presented with a problem where you're asked to find the shortest path between A and E. Now, you can see here we have all other nodes here, B, C, D in between. To use Dijkstra's algorithm, one thing you may want to do is create a table that looks just like this. And in this table, you show all the nodes. Now, the next thing we're going to do is to start from our source node. So where we're starting from is A. So we'll start by exploring that node. We'll check. A to A, we do know it's going to be 0. So because A to A is 0, I'll put down 0 there. And I'll put the node where it's coming from, which is A. Then I'll move on to explore A to B, the distance between A to B. And I know that it's 3. So I write down 3 here. Again, I'll put down the node that I'm exploring, which is A. A to C. Now A to C doesn't exist, and I'll represent that with the infinity symbol. I'll do A to D. Now A to D is 1. I'll write down 1 there, and then once again I'll write down the node that I'm exploring. And then I'll check A to E. A to E does not exist, so I represent that with the infinity symbol. At this point, I have now explored all nodes linked up to A, and I'm done with A. The next thing I'll do, I'll look for the node with the smallest weight or the shortest distance, and that node is D, which currently has a weight of 1. So I'll bring down this node. I'll say 1A, and the node I want to explore now will be D. And the best weight, so the best distance from D to A is 1, and I'll just put that 1 there. Now D to B is 6. 6 plus 1 is 7. Now I can tell here that 7 is way larger than 3, which is currently the best node to B. So there isn't any need for me to go through that route to get to B. So the best known path to B is still coming from A, which has a weight of 3. So I'll just bring that down here. And I'll go on to explore D to C. Now D to C is 3. 3 plus 1 is 4. So I'll put down 4 there, and I'll write my D. D to E is 8. 8 plus 1 is 9. So I'll come down here, I'll write 9. And that's coming from D. Okay, so I have now explored all of D. The next thing I'll do is to look for the node with the smallest weight here, and that node currently is B, which has a weight of 3. I keep interchanging weight and distance. Okay, so the current best known distance between A and B is 3. So I'll bring down this there, and I'll explore B. I'll put 3 there. Okay, so I'll move on to explore B now. Now B to C is 4. 4 plus 3 gives me 7. Now I know that 7 is larger than the best known node to C. So there's no need for me to represent that, so I'll just bring down 4D there. B to E does not exist, so I'll still write down my 9D, because that's the best known path to E at the moment. I have now explored all of B. So I'll compare these two now. So the nodes left to be explored are C and E, and that's one of the things with Dijkstra's algorithm. With Dijkstra's algorithm, all of the nodes are mainly explored. All of the nodes to the destination nodes are explored. So you can see here now, if I bring down C to be explored, which currently has a best path to C is via D with a weight of 4. So I'll pull down C there and I'll say 4. We've explored all of A, B and D. So the only node left to be explored now is E via C. So C to E is 2. 2 plus 4 is 6. Now 6 is smaller than the 9 we have here. So I'm going to replace that path now to 6, the weight to 6, which is coming from C. So I'll put down C there. At this point, I have explored all of C. So the next node I have now to explore really is A. And that's coming from CC. And at this point, most exam boards like to see that all of the nodes have been explored. So it might help if you just write down the E6 there as proof that you've explored A6. And by this point, I can say that I'm done with A. So the best path from A to E, the shortest path from A to E is to get this. I'll just go to E there. I'll write my E there. Now best known path to E is C. I'll put C there. I'll go to C, and the best known path to C is D. I'll put D there. I'll go to D. The best known path to D is my source path, which is A. So our shortest path between A to E is ADCE, and the distance or the weight, is 6. Okay.